我们接下来就来欢迎 Cesar Harada。
Hello, everybody. Thank you. Thanks very much for having me. So I would like to speak about open hardware for the environment and how we can use technology to improve the environment or social issues. I was invited to speak last year at the Shenzhen Faire, so I didn't want to show the same project, so I will only show new project from this last year. Okay. Also, more and more in our makerspace, Makerbay, we have been implementing the technique of design thinking. And so I wanted to talk about the design thinking and how makers can use design thinking. Who here knows about design thinking? Can you raise your hand? Design thinking, you're familiar? Okay, actually not so many people, so it's good. So maybe it'll be interesting for many of you, hopefully. So when you say the word design thinking, oftentimes this image comes up. People using post-its and stickers, put it on the wall, get some new ideas. The design thinking method that I'm going to explain to you is the one that is kind of the original old one by Stanford, D-School, and IDEO. So there are different steps to come up with new ideas and to implement them. So the first is to use empathy. So how do you connect with the problem you're trying to solve? The second is how do you define the problem? So to transform the problem that you observe into something you can kind of break down. Then how do you come up with new idea? Ideate. How do you build a prototype and how you test it? So this procedure is very natural for most of you, I imagine, as makers. But if it's more systematic, sometimes it can help you to be more productive or go a bit faster in your process. So some people use the design thinking not in a linear way, but in a circular way. So you have to go through different cycles of innovation. I will give you lots of examples afterwards, but I just want to start with the theory. And some people also say that you can do all these steps in parallel, that you can have new ideas as you're prototyping or as you're getting feedback. So some people also like to simplify the process of creating in this simple drawing by having a complex system at the beginning and then going more and more simple from R to D, research to development, complexity to optimization. I like to break it down to the 3 steps which for me speaks to me more. The first is empathy, so use the heart. So as makers, how can you use your own feelings to motivate your research? Then to touch, to understand the materials, to understand logic, and only think as the last step. Because when you're in school, typically we teach you very well to think, but we're not really trained to feel or to touch. So I will use those now projects to demonstrate how we can use design thinking as makers. So the first, I would like to speak about one dog. There's this one dog in my neighborhood in Hong Kong, and he's missing a leg. And we just teach to the student about laser cutting. So just teach them a technology, and then we ask them, what do you care about? And one of the students say, well, there's this dog around the workshop, and he's missing a leg, and he's always dragging his face on the floor, he's bleeding on the floor. We're very sorry for the dog. So the students start to come up with many different designs. As makers, they kind of compete or collaborate of ways they could solve the problem for the dog. Instead of building right away, they enact. So it means that they pretend they are the dog. One of the students said, what about if we attach the front leg and the back leg? Maybe we can move the 2 legs like this. But actually, if you try yourself, it's really inconvenient. It doesn't really work very well. But doing it physically help you to try the idea even before you start making something. Oh, sorry, going backwards. So then also to make something at the right size, we make a fake dog because we don't want to bother the dog that is handicapped all the time. So we found some ways. And then some of the students, they start to develop different groups and develop different prototypes in parallel. One of the group wants to make a robotic arm. Another group wants to make a 3D printing wheel that can be attached to the leg. And in the end, some of the idea failed, and they came up to become one team. And so this is the team. So the 3 teams become one team. And then they make this prototype of the dog, and then they tried it. And so, of course, it's not easy to make the machine that's going to work for immediately, because the dog has been injured for 2 years. But like this, they get to try an idea and to try to solve a real life problem. So what I would like to make the point here is that you can use maker skills and maker education and the design thinking process to teach this process of being creative and trying your idea in reality for the kids. I hope that's. I thought there was a video. Well, anyway, of course it doesn't work perfectly. So some of the kids were very sad. It's not working very well, and they scratch their head, and they will come back several times to help the dog. But I just wanted to show this that this process is very convenient. If you're in a STEM or STEAM education sector, and you want people or kids to learn about technology, this is, I think, a very good process. So this design thinking we apply to a very individual local problem. One dog, one prosthetics, very simple. But let's look at a bigger, more complex system and how you can apply design thinking to a more complex system. Hong Kong has a big trash problem. If you go to the beach in Hong Kong, and I think it's the same in many places in the Pearl River Delta, you see there's lots of trash. Many people, they go and they collect this plastic. But right now, we don't really understand the mechanics or how the trash travels in the ocean, where it comes from, where it goes, who actually puts in there. And so the best way, now we have to track plastic in the ocean, is that we take those big boats, and then we take a net, we collect the pieces of plastic, we look at the pieces of plastic, and then we can make a map of it. This has been taken about 20 years, but about 2 years ago, we came up with this map that found that 80% of the ocean have plastic in them. And it's estimated by 2050, there'll be more plastic in the ocean than there'll be fish. So this is a very serious problem. So we collaborated with Seeds or with other hardware company, and then we started to design some drifters. The drifter, the idea is if we can create some fake trash and then put it in the river system, we can track where the trash is coming from and where it's going. But the problem is by doing this, we create more trash that go into the ocean. So we don't want to have this impact. So we try to find the most environmentally friendly way to develop this sensor. So we first make the first version. You see it's quite big. This is Eddie. And so we work with the WWF, it's the World Wildlife Fund. And because also their reputation is in the game, we have to develop some really green electronics. So at the beginning, we build all ourselves, the database, everything, to collect the data. And when we do that prototype, we discover something new. Is the trash that you see on the beach, you will see it on another beach. You will see it coming many, many times. Actually, the trash you see in one place, maybe it's going to move 10 to 10 different beaches. So in Hong Kong, you see the trajectory of the trash is not straight at all. We need to develop new method because the way we measure plastic, the way it moves, is not at all what we expected. It's much more complicated. Depends on tides, depends on the wave patterns, depends on the wind patterns, and it's a very complex system. So we need to have more intelligent strategy to catch this plastic. So we put our drifters in the ocean and we start collecting them, and we're not happy because it's plastic, and we lost one of them. So we thought, what about if we replace the plastic of our drifter with a coconut? So we just go to the supermarket, we cut the coconut, we drink the juice, and so this is the best part of the experiment. And then we start to replace as many electronics components as we can with organic material. Then we want to make sure that the electronics are safe. So instead of using the plastic casing, we make a replacement for plastic, which is a composite material made of wax and cork and cotton fiber. So it's waterproof, it can float, and the fiber can become good for impact absorption. So we make many different prototypes of plastic replacement, and then we try again with the coconuts. So this is the third version. Then we work on optimizing the battery. At the beginning, we have 2 batteries. Or we have, this is already third or fifth version, we have only 1 battery, we optimize the software, reduce the refresh rate, reduce the size. So we also work closely with Seed Studio. Xiaoyang is, where are you, Xiaoyang? So she also helped to make sure that the manufacturing is as clean as possible. But the dream for us is to go towards the paper PCBs because our electronics will be lost in the environment. So we really want to make sure that as much of it can be biodegradable. Then this is Maker Bay in Hong Kong. And so we do all the assembly of, we prepare the assemblies for 110 ocean drifters in our makerspace. And so we build a repository. You are welcome. All the data, to get all the data and the design is open source, of course, in this GitHub. And then we work with 11 schools. So again, it's about STEM education. So we teach, for example, the girls with the girls in school, and what it's about. We teach them about environmental pollution. We teach them about electronics, and we built 110 drifters. And so we can verify the movement of the ocean currents. So that's for one. But we can make a model. We are trying to make a model of prediction of where the trash is going to be. So instead of just going to collect the trash and make a map many years after when the data is already out of date, we want to predict where it's most likely going to go. And so this is the map. And one of our drifters, which costs less than $50 US, 500 Hong Kong, travel from Hong Kong to Taiwan in about 1 month. So a very low-cost drifter can cross a big piece of the ocean, and so you can make distributed computing for environmental sensing at low cost. It's possible. So again, the idea is that you can use empathy for the environment, design, prototype, optimize for lessen environmental impact. Oh, sorry, I made a mistake. So that's this time it's a regional impact. It's in Asia, because this one, the life of the battery can last only for a month and a half, so it cannot go all the way into the Pacific Ocean. But now I will talk to you about a project that is happening right now. Maybe you know that the coral reef are dying. The coral reef is just like the jungle or the forest. In my opinion, is the most important ecosystem on the planet. All life, including ours, come from the ocean. We evolved from the fish. And so the corals is the most fragile environment. Small variation in temperature or acidity, and the coral reef can be really destroyed, which is happening. It's predicted that we'll lose 95% of coral reef by the mid-century. So this is also a very dramatic impact on climate change and ocean chemistry. So when you study coral reef, you can observe mainly two things. One is the color. The second is the size. The way we measure coral reef today, this is still the way we do it. We take a quadrat, it's a square, and then you swim at the bottom of the ocean, you put the quadrat at the ocean floor, and then you take a picture. And then you look at the color of the coral reef with a small piece of plastic that you put in the water, and you take a picture to compare the color. It's very slow, it's expensive, it's dangerous for people to dive up and down like this so frequently. So with my students, they are age maybe 13 years old, we started to hack some ideas. We come up with some crazy designs, and the idea that stuck the most was to develop a replacement for the laser, for the quadrat, and use laser. Maybe you've seen those ones. They're used commonly in construction, and they are very cheap. Those lasers become very, very cheap. And so we started to hack the laser and try to make it so that we can actually project a square on the coral. Instead of putting a mechanical device, what about if we project a laser? So the students learn to build and hack the electronics. They learn how to align the lasers on short and long distances. We build the waterproof casing, and then we go outside and do some mapping exercise. So we started to make the first test in Hong Kong, and that was pretty successful. We worked with a local coral scientist, and they think that this could be essentially a replacement for mapping coral reef. And this would be much cheaper and much faster, so we could scan a large area of coral reefs. So just 2 months ago, we had a grant. Now we have a small grant for about 10 students, engineering students from Hong Kong, but it's an open source project, anybody can join, to go to the Philippines to map some of the world's most diverse coral reefs. And so we start to build the generation maybe 7 or something like this. And so this one is basically like a boat and a submarine combined together, projecting laser. We tested it last week in Hong Kong. And so we're going to go in this area called Mindoro in the Philippines. So again, we can use design thinking to address problems and technologies that can apply to actually change the climate. If we can save or at least understand and mitigate the effect of climate change on corals, this has huge implications for everybody. So I wanted to show you that you can use your maker skills for local issue, for regional issues, and for local issues. And you can use the same method. I'm not saying that design thinking can solve every problem. I just say that it's a nice method to try to do some rapid prototyping initially, and that's very useful to implement into STEM education. So why I like to present you this project is because I'm a maker and I'm very excited to make things, but first I always ask myself the question, why am I making something? Is this what I'm making the world better? The second is if my idea is okay, if I want to become a pro maker, I'm a pro maker, but if I develop something, can it be useful for somebody else? And this other person, can they afford my technology? And if they cannot afford it, can they make it themselves? So I'm an advocate for open hardware. And the last, and it's very important, is that there's a lot of people doing great things, but you have to document it so that other people can show you are wrong, they can criticize you, this is how you can make progress, and they can also make something better than you. Because if you actually care about coral reef, about all these things, then you have to let other people build on top of your work. So I will not go too deep inside of this, but there are many design and engineering methodology to reduce environmental impact, to improve social impact. But I first also came in Shenzhen because I was so excited that I can make things faster, cheaper, I can make more money, I can have more fun. But now I shift for me it's the maker paradise. But now I'm a pro maker, I'm thinking, okay, how can I make not faster, but how can I make better product? Instead of making always cheaper, how can I make it so that it doesn't have too many impact or externalities? Instead of just thinking about the money, how can I be more impact? Instead of being more fun, how can I make it more meaningful? So for me, it's a new type of fun. Now I'm a pro maker, I feel like my new type of fun is not just to do something funny, but is to do something that I feel can contribute to the community. And we call this impact invention. So you invent, and your goal is to impact. In our makerspace, we have used this method called impact invention to address social and environmental issues. And you see, you have all the green boxes are projects we have done in the last 2.5 years. We have built autonomous electric cars. We have built wheelchairs. We have built helium balloons with thermographic imaging. We have built a tent for the homeless. We have worked with the refugees. We've built prosthetics for the kids, for the dogs, VR system, wind turbines, hydroponics. We helped several companies to become successful in Kickstarter or to become commercially successful. So now I think a lot of people here in this room, you are familiar with open hardware. And you know that it can help you to get new collaborators. It can help you to work with other industry. It can help you to get money from the government because your project is visible. But I would argue that you can do the same to actually improve science. You can use the same methodology to contribute to social science, to environmental science, to do citizen science. And many people say everyone can be a maker. We say also everybody can be a citizen scientist. A few months ago, we organized a little bit like Maker Faire, but we wanted to organize like a Maker Faire but focus on social and environmental issues. And we call this the Citizen Science Fair. It was the first time in Hong Kong, or in this region. So we organized this fair, and we would like to invite all the makers here who are interested in social and environmental issues to join us. We've done it in Hong Kong, but we're very happy if you do the own version in Shenzhen. So we teach people about air pollution, how to measure water quality, how to do microscopy, how to do DNA extraction, and so on and so on. So we're very grateful for all our partners. And so I hope I can convince you a little bit today that you can implement design methodologies to your STEAM and STEM education program, and that you can use open hardware to improve the environment. Thank you very much.
Thank you, Cesar, so much. Please stay. I just want to say that every time I hear you speak, I'm, again, inspired and touched. I think the theme of the Maker Pro that we have this year, I want to say this again to everybody, reiterate that Makers Go Pro. When we say that, it doesn't mean that you have to be in a market selling an actual product. That doesn't necessarily make you, it makes you a professional, sure, in that sense. But what we want to define Maker Pro also is how do you take your skills and knowledge and then apply it to something that you really, really care about. And then when we talk about the industries of the future, I think we're really moving towards a future where sustainability, social impact is a part of what business should be about. So I think my question for you, since we're changing computers again, is being based in Hong Kong and so close to Shenzhen. Hong Kong, as everybody knows, is a financial center of Asia, and then Shenzhen is a city that's amazing. It's paradise. But then again, we're also looking at the supply chain or commercial market that's making a lot of things that aren't necessarily so well thought of, or it's easily that a lot of things get made without having that much time. Yes, so I don't want to say that, but yes, waste. So what I'm trying to say is, when you're doing this at Maker Bay, what challenges do you feel in these two cities? What challenges do you face? Because you're surrounded by, people that aren't necessarily aware of these issues. They only care about me. That's a Shenzhen question we get all the time. How do you make money? So, how do you think we can start getting more people aware about it? And in the maker spaces that we run here, how do we get more people involved? What are the minimal things they can do?
So when you are doing some consumer products, you are making a product that you're going to sell to somebody to use for themselves. You also do the B2B. You make a product that's going to be used by a company. So you make a product and it's going to be used by more people. The problem is that when you do a social or an environment product, you're actually doing something for the public good. And so it means that you cannot expect money from the public good. And so that means that you have to identify who is going to become your client, basically. So it's not as straightforward, because oftentimes maybe it's going to be a university, an institution that needs to develop new instrumentation. Maybe sometime it's going to be a nonprofit that does social impact. And so then you need to work with them to write a grant so that they have a technology component into their grants. So you can really help them to implement the program.
Yeah, so the money is going to come from someone. It's just not necessarily the consumer market.
Exactly. And so that's a lot of strategy to develop around it, because that's not a very well targeted market, because it's not usually where the money comes from. So that's the first. The second thing is that once you have proven that you have a track record of developing this technology, then you can have some credibility. It takes time. So even if you're doing something that you truly believe in and it doesn't make money right away, it doesn't mean that you should give up and it doesn't have a meaning. Actually, it's the opposite. Actually, when you do something that is not sanctioned by immediate return, it's likely that you're really touching something that is the future. If you think about, for example, say Bitcoin, it's in 2011, it cost nothing, and now it's skyrocketing like crazy. Everybody's talking about it. And I think it's the same for social environment technology. Now it's a very new emerging field. But because our society are changing so quickly, I think this is a growing field.
I do agree. You never really know where your project is going to take you. If one day in the future becomes there a market for it, there's a need and demand in our daily lives, then, there's always that. Thank you so much. Sorry. All right.